Math time. We have like 10 more skills before the timer is up. We'll see if I get there. I should get 12 questions. If this is... Alright, I could also do this one. Let's see and say first. 8. Contestant on the game show. Spin a wheel with 24 equally sided segments. Most of those segments show different prize amounts. But 2 of them are labeled bankrupt. Suppose a contestant is going to spin the wheel twice in a row, but one of the outcomes does not affect the future outcomes. Okay. That neither of them, so that'd be 22 over 24 times 22 over 24. So we have 22 divided by 24 squared. So that's actually a bit higher than I thought it'd be. It's 84%. Oh, this is 0.084. Luke is playing a trivia game with multiple... Luke, my homie Luke. That's it. Luke is playing a trivia game with multiple choice questions. He runs out of time and needs to guess on the last 2 questions. Each question has 4 multiple choice options, one of which is correct, so Luke has a 1/4 probability of guessing to any of the given questions. Let S represent the number of answers in the pair. What table represents the theoretical probability distribution of X? It should... Question 1 and question 2. C is correct, I is incorrect. Correct. 0.01, it's 12.5%. So 1/8, 1/4, oh wait, it's more than that because it's... Oh, that's ugly. I was hoping it'd just be simple. It's not though. These 2 probabilities are the same. It's 0.3/4, 0.75 times 1/4. So 0.25 times 0.75. Or 1/4, or 3/4 times 1/4. That equals 3 over 16. 3 divided by 16. Yeah. 3/16. Well, I get 0 right. That's 3/4, so that's 9/16. The chance to get 1 right is 3/16. The chance that you get 2 right is 1/16. Probability P should add up, so you get 6 plus 6 plus 1 plus 9 plus 6 plus 1 is 16. Seems right, yeah. Not looking good in time, 4 minutes. Okay, you can't see the clock, but I have the hitting clock right here. There's 4 minutes. 4 minutes, 50 seconds now. Not good in time. Let X represent a player's net gain on the spin. For example, the spin lands on space where the contestant wins nothing. X equals -10. Expected gain. So x yeah, so we have -$10, and then we have $20 plus $5 plus $5, all divided by the 6 spaces. So it's -5, which is honestly pretty awful, considering this, but -5, 5, 5, -5, yeah. Airlines are usually willing to overbook flights. And give them a large credit. An airline tracked how many passengers needed to be moved off a certain flight in each of the last 500 times that flight ran. Based on these results, which graph represents an approximate probability distribution of the number of passengers moved off this flight on a random day? So we have so what's the chance I'm going to get moved off this? They just want a number? No. Probability, so we have 500 over 500, and then we have 290 over 500, 160 over 500, 30 over 500, 20 over 500. That's 290. That's 0.58. 0.58. 160 divided by 500. 0.32. Normally outliers aren't bad where you have a, what's that, 42% chance of getting hooked off. I'm just assuming that just seems rather high. 0.06. 20 divided by 500. 0.4, yeah. 0.04. Bloop, bloop, bloop. Bloop, bloop, bloop. That looks right. Boop, boop, boop. 0.3 is wrong. That sounds about right. Yeah. It's 0.58. A is wrong. Moves off flight. Yeah. Let's see. So 50 people were surveyed about their preferences between chocolate and vanilla cake. The following two-way table displays data for the sample of people who respond to the survey. In the survey are the events female and prefers chocolate, mutually exclusive. So you have female, you have some female who mutually exclusive. I think it is, yes. No. female, or she prefers chocolate, that's 15 over, no, 15 over 22. I forgot what mutually exclusive is. One directly, guys. You cannot have a prefers chocolate female. That's wrong. It's female, so that's 15 over 66, or prefers chocolate. That's 33 over 50. Plus, that'd be 18, so that's 15 divided by 22 plus 18 divided by 33. 18 divided by 50 plus this 0.8, 0.8. 22 divided by 50, and then you have 18 divided by 50, 0.8. Emil and Samuel are designing a game. In each turn, a player rolls 3 six-sided dice and adds numbers showing on each page to determine how many points they get that turn. Which statement is correct based on only the expected values? See, the lowest point of the term is 1.1 plus. Okay, I see this. It's a sum. That person's right. 100 times 10.5. I think they're both correct. Let's see. That average number of turns, the sum, will be very close. I think both of them are correct. Unless I'm missing something. Yeah. Hugo, my homie Hugo. Hugo plans to buy a pack of baseball cards until he gets the cards that are his favorite, but he only has enough money to buy at most 4 packs. Suppose each pack has a probability of 0.2 to contain the card Hugo hopes for. Find the indicated probability. So let's see. P of greater. So we have 1 minus 0.02 minus 0.016, 0.64. Greater than or equal to. It's 0.08. because you have one pack that's 0.02. And so you just add all the probabilities until you get 1. Indicate the indicated probability. I don't see how this is wrong. Okay. The first 2 digits of a data entry in most real-world data sets are not uniformly distributed. First digits are often followed by a particular number described by Benford's law. Which graph correctly displays this probability distribution? So we have I can probably go for 15 more minutes. Probably take 10 though. You'll speed up. First, it goes up high and then goes lower and lower and lower. So not B, not C, A. Let's see how 1 isn't right, because you have highest probability, and then the probability D afterwards gets smaller, 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 smaller. It doesn't spike and go down. It doesn't get, yeah, I don't see how that works. It doesn't follow the graph. Elaine loves to go fishing. Each time she catches the fish, there's a 70% chance that's a northern pike, and there's a 30% chance that's a wally. Let X be the random variable that she catches the number of northern pike Elaine gets if she catches 2 fish. Find the expected value of the number of northern pike Elena catches. So let's see. The expected number of northern pike is 70%. And if she catches 2 fish, then the chance is 49. Oh, that's interesting. There's a high chance that she gets 2 northern pike than she gets 1 northern pike. Let's see. I see. So 0 times 0.009 is 0. 1 times 0.42, 0.42, plus 2 times this is 0.98. 0.42 plus 0.98 is 1.4. She expects, the expected value is 1.4. And that makes sense. I have to say that makes sense, the rest of it doesn't sound correct. Contestants on the game show spin a wheel of 24 equally sized segments. Most of them show different prize amounts, but 2 of them labeled bankrupt. Suppose that some contestant is going to spin the wheel twice in a row. Here are some of the events. Consider the probability. Let's see. What does this represent? B1 lands in the bankrupt. B2 lands in the second bankrupt. Are they mutually exclusive? Okay, so it'd be 24 over 2 times 2 over 24 because you're not. It might be actually 1 out of 24. I'm talking about the first spin. Yeah, so it'd be 1/12 times 1/12, which is 144. That both land on the bankrupt. B. Bankrupt 1 times bankrupt 2. Let's see, contestants are on a games wheel with a wheel of 24 equally sized segments. Most of these segments show different price amounts, but 2 of them are labeled bankrupt. What is the probability P of bankrupt 1 and bankrupt 2 equals the probability of bankrupt 1 times the probability of bankrupt 2 over bankrupt 1? What does bankrupt 1 and bankrupt 2 represent in this context? It's not going to be A. I'm at 10, so it's like I can't go back. I just can't. Bankrupt 1, that's 1/12 times the probability of one and 2. It has to be this. Whew. Thank you. Steve and Alex aside, my homies. Give me a second. There we go. Steve and Alex decide to roll a pair of fair 6-sided die to determine who has to do their laundry. If the sum of 1, 2, or 3 of them, then Steve will do the laundry. If the sum is 10, 11, or 12, then Alex will do the laundry. If the sum is anything else, they'll roll again. Is this a fair way to decide their laundry? Why or why not? 6-sided die. If the sum is 1, 2, or 3. I think that's right. Steve and Alex decide to roll a fair 6-sided die to determine who has to do the laundry. Is this a fair way to decide who does their laundry? Why or why not? 1, 2. Should be the same. No, it might not. I think it has to be the same. It's a pair of 6-sided dice. I'll be quiet. You'll go in 5 minutes. Ugh. Oh, I'm gonna have a leave. 5-minute timer. Okay. Spent 30 minutes on this. I can please skip 5 minutes. Steve and Alex decide to roll a fair 6-sided die to determine who has their laundry. If the sum is 1, 2, or 3, then Steve will do the laundry. If the sum is 10, 11, or 12, then Alex will do the laundry. If the sum is anything else, they'll roll again. Is this a fair way to decide who does their laundry? Why or why not? Something's... Ooh, you can't get a 1. You can't get a 1. So there's a higher probability that Alex will do the laundry. Ooh, they were tricky. They were tricky, he says. 1, you cannot get a 1. And so that just leaves them with a 10. That's... Oh. Ooh. Because Alex... Ooh, that's naughty. Adeline sets up a taste of 3 different waters: tap, bottle and glass, and bottle and plastic. She puts these waters in identical cups and has her friend taste each one of them. Then her friend tries each water to decide what water is in each cup. What is the probability that Adeline's friend correctly identifies each of the 3 cups of water? Probability P. I think it's this one. Why is it this one, though? Oh. That's great. Oh, clean through. So happy. So happy. 14 skills. That's interesting. Why did I get 14 skills? And if you get all the level, then you level up. Ooh, that's very interesting. So, goodbye.